Okay, we can start. First of all, I would like to remind you there are lightning talks right after this presentation. And now please welcome Stanislav with his presentation of HTTPS certificate not trusted.
Hello, welcome everybody. I didn't expect so much people, so I'm glad you came. Let me introduce myself. My name is Stanislav Židek, and I'm working at Quality Engineering in Red Hat. In our team, we are dealing mostly with security-related packages, and we are kind of concentrating a lot on testing SSL and TLS. But today my talk is going to be really beginner-oriented. Don't expect anything fancy. I just got an idea this is something that happens to everybody, and if someone wants to know more what's happening, it might maybe be beneficial to give some basic overview of what's happening. Okay, so the topic is HTTPS certificate not trusted, which probably everyone has sometimes seen in their browser while connecting to some probably badly configured server, but maybe it doesn't have to be that way. Bit about motivation, we are doing that because this is the thing you can really see with your own eyes, even if you are not expert in public key infrastructure and such things. What we want to achieve here is get some better understanding of what's happening under the hood, and how we want to get there. We want to get a bit more familiar with some command line tools that can help us debug some common problems that happen all the time. As I already said, it's really for beginners, so don't expect anything fancy. Let's start with a bit theory. So what we are basically what we want to address, or why we have the problems, is because we want to address the key distribution problem when we want to communicate securely. What we use, let's go from bottom up. So we start with public key cryptography, which is a great thing, and it helps us with the key distribution really a lot. Because we don't have to find some secure channel to exchange some secret key with someone and then use it and keep it secret all the time. It makes it easier, a lot of easier. I can go to you and say, here is my public key, everyone else, you can see it, no problem. But after you see it, you can kind of communicate to me securely. So this is a huge help with key distribution, but it doesn't address it whole. The problem is you cannot be really sure it's my key. You can be if I now show it to you, but you probably cannot when you see it just somewhere on the internet and there will be written, okay, that's key of Standa, everyone trusts it. It might have been some attacker or anyone. So the next step is the certificate. Certificate is a thing that tries to bind some other information to that public key, to associate it with some data, and more that someone attests that it's correct. So typically, I will take my public key, I will put some information to that, it's mine, it's valid since then, and it's used for I don't know what. Give it to some certification authority, which in theory is some kind of institution that other people also will trust. Certificate authority sign this certificate, after some checking that it's really mine, key, and so on. And after that, theoretically, I can put this certificate, and everyone who downloads it can check okay, this key belongs to Standa, and it was attested by this certificate authority, and I trust this certificate authority, therefore I can be sure to communicate with him with this public key. One step further, this is not as simple, those certificate authorities can be used transitively, so even if you are a certification authority, you can like not be known to everybody, but you can be attested by other certificate authority who signs again your public key or you creates your certificate, and like if then like even the certificate authority can be trusted because someone trusts the upper level certificate authority. So how it typically looks like, or what should the structure be? Like there should be some root certificate authority, which ideally everybody should trust. Then there should be some intermediate certificate authorities, might be one, might be none, might be theoretically a lot of them, which you don't have to know if the chain is okay, like you only need to trust the root one. And one of those intermediates, like it can go by a lot of levels, could sign your server certificate, because the server is the entity you want to trust when you are connecting somewhere. Yeah, so typically you are connecting to your bank, you want to know you are really connecting to your bank, so no one steals your credentials. And that's how you check it. In practice, those certificate authorities you trust are typically somehow pre-installed in your system, typically in browser or somewhere else in the system, because not only HTTP is using them, but the whole situation could get really complicated. And so let's have a look at least some like basic examples what could go wrong. Okay, first situation, I am connecting to server, in this case localhost, but it could have been any server. Like in this presentation, localhost is the thing I want to connect and I want to achieve. I see this warning in Firefox. This warning actually doesn't say much, but we are experts, we want to debug, so we click advanced to see what's happening. And we got error code saying something about bad domain. You can probably guess what it might be, but let's have a like deeper look in that command line as I promised. So what shall we do? Let's first retrieve those certificates that the server serves us, and we can do that quite easily with OpenSSL command, which has a lot of useful subcommands, some of them used for debugging. For example here, the S client, it's like TLS client that can help you debug something. We can specify where should it connect. The important thing is that second argument, the showed source, which will make the S client like print the whole certificate chain. Normally it only writes the server certificate. So here we can see everything. It will be useful not in this example, but later. And possibly if you, for example, debug some other certificates on your local host, or you are debugging some more complex scenarios when there are more certificates at the same IP, you can specify the server name and like it's connected with server name indication and so on, and we don't have time to get into it, so we can forget this one for now. Okay, so I connected to that server again, and I can see that something is wrong. Here I am expecting to be connecting to localhost, but the certificate that's being served has the subject that here the S means subject, it's like the identification, and there is some other name than localhost. So that was easy. There was like even the indication in the S client, but we can get a bit deeper. Like if we take this blob, this begin and certificate, like this thing, we can, for example, save it into file, and we can get some more information about this certificate, which might get useful. Like not here, here it's obvious, but anyway, let's have a look what's there. We will use another subcommand of OpenSSL. We tell him like we want to see like what's in the certificate. We are not interested in blob, that's the no out, and we specify the file where we save this certificate. And when we print it, we actually get what we expected. There are that attributes that should be in the certificate, and the one that's interested is, as I said, in the subject, and there is the name that we are not expecting because we are connecting it to some different server. A slight note here. I am practically lying in this example. Normal way of doing these things is through the subject alternative name extension. So probably when you see a new certificate, the software is not really taking care about what's in subject. It's looking in one of those extensions because certificates have a lot of extensions, and this is kind of important one. And it has the advantage you can specify more names there or anything. So that's usually the first thing you want to check. This is old behavior. Okay, let's get to next example. This one is simple again. We are seeing the same warning, but after clicking the advanced button in Firefox, we see expired certificate, which is probably again obvious, but let's see what's happening inside anyway. We get the certificate again with the sclient command, as I showed in the previous example. And here, when we again inspect it with x509 command, we can see the validity period is wrong. Every certificate has to have some validity period, and it should be valid only in these times. And here you can see that this certificate, it's okay, but it was valid 2 years ago. If there was 2017, everything should have been okay, or 218, it's already past 1:30. Okay, these were simple examples. Now let's get into some bit more complex ones. Now we will not be so interested in the attributes of the certificate that much. We will be more interested in the certificate chain, the thing that's related to public key infrastructure I taught before, certificate authorities signing some intermediate certificate authorities, and so on. Again, there might be problems, certificates might be different, and so on. So this is kind of generic error, which tells us basically that there is something wrong with certificate chain, but we don't know what. And there can be many situations when this happens. So let's look at the first one. This is again shortened output of a sclient command. And here we see that the server serves us only one certificate, and it's self-signed by itself. This is again something you don't see that much, but it's definitely the server is not even trying to serve you something that you should trust, because there is not even an attempt to give you some certificate authority that might be installed in your browser. So this cannot be trusted at all, at least in default configuration. You can make it, but anyway. Problem might be different. This one seems a bit better. Now you see the server is serving the server certificate, the first one, with omitted this, so it fits into the slide. And it also serves the certificate authority certificate, and it kind of creates the chain. Here the problem is that, it's indicated in the command name, that this certificate authority is something unknown to your system or to your browser. So therefore, even if this chain is okay, you have nothing to compare it with. Everybody can create some certificate authority. The goal is, when you have some public server, usually to have it signed by some CA that is pre-installed in browsers that you can attest somehow. Anyway, even if this example doesn't work, we can at least check that the chain is correct, that the server certificate is really signed by this certificate authority, and that's the third and last OpenSSL subcommand we will use today, and it's OpenSSL verify. And here we will typically specify, like, give him the certificate authority certificate in a file, and here the server certificate. We are practically here telling the OpenSSL verify command that, okay, what's in that CA file, let's pretend we trust it by default, and just check the certificates that are like being thrown here. And here you can get this output if the chain is constructed well, that, okay, the chain works. So you can kind of imagine that the problem would be that you are not trusting just that CA. You can import it in the browser, and in that moment everything could start working fine, because now you trust it, chain is correct, you can connect to the server, and so on. Situation might be different, even though like you can still see something like this. The certificate authority can be, for example, some other one. Someone generated something with the same metadata but different key and so on. And then if you run the same OpenSSL verify command, you will get an error, and now you can kind of see that, okay, there is some server certificate, there is some CA certificate, but like that server certificate is definitely not signed by that CA one. So now you see like there is the problem in the chain, and it like doesn't even link together. Even if you would have trusted that unknown CA in here, like server is serving you something bad, and you are not going to help yourself. It can be even more different. Let's again imagine that that error we had for the last time, the unknown issuer. Here you see you are getting, like, again, server certificate for localhost, but that is being signed by some, let's say, intermediate certificate authority. It's nice to see it in the name. Like normally, you should debug to like see that it is some intermediate certificate authority. And this example starts to be maybe a bit more tricky. That's quite common, for example, when some certificates on some servers change, that even though there is some like longer chain, typical server certificate, intermediate CA, root CA, even if you trust the root CA, it might not be enough, because for you to be able to verify it, you must see, or you must have the intermediate certificate somewhere, so you can construct the whole chain towards the root CA. And here, like, this situation is interesting, because that's something like, I cannot connect to the server, like, there is some certificate problem. Can you try it? And other people could be like, yeah, I can connect like there without any problem, so what's happening? What's usually happening is that your system, if you have the problem, you don't know that intermediate certificate, and that people for whom it works, they have it, for example, cached somewhere in a browser or in some NSS database or anything. So even though like you are getting correct certificates, server here is not providing enough information for everybody to be able to verify it. And like, it's interesting that it might work for someone. It usually works for people who already saw that intermediate certificate somewhere before it got cached, but it doesn't work, for example, for people who didn't see it, fresh install, anything, even though practically it's the same. Here, it's definitely the server's fault, because it's not serving the whole chain. It should always send the server certificate and all the intermediate certificates linking to some root CA that browsers should trust. If you want to verify that like more complex certificate chains, and when you want to somehow indicate like, okay, I want to trust a certificate authority, this one, but then there are some other intermediate certs, and I want to see if it like links down to the server certificate I want to test. You could use option again for OpenSSL verify untrusted, where you kind of provide him the cache that your system might have. So this command practically makes sure that while trusting only this root CA certificate, you can like link it together to this server certificate if you know these intermediate certificate authorities. Yeah, and that's how you check like the situations that are a bit more complex. Okay, it was fast. It was just in time. Conclusion is, like, we have only talked about some really basic, typical problems. I wanted you to see the commands you can use in command line, because we are kind of hackers. We want to dig in command line. No one wants clicking and so on. But the reality is much more complicated. If only those were the issues, like probably everybody would be happy. There are many things where it can be much more complicated. There can be some bad extensions. For example, that server alternative name I already talked about. Browser behavior might change, like some certificates that worked before doesn't have to work like after a new version of browser. Even the same certificates issued like on different dates might not work because some browsers are programmed like if the certificate was issued before this date, we are allowing this, but not after this date. They are like, in general, they are trying to make the situation like more strict to get some better overall security. But again, it may cause some problems. If you are interested in this topic, we could definitely have a chat. Possibly if you are probably some kind of student looking at some project, we can most probably make something together. You can do some verification of your own, dig deeper,